Hello everyone, how you all doing? Enjoying the conference? Good lunch? I had my fair share. I'm really glad to be here at the first ever DevConf. I'm actually really glad to be here. I'm not sure what's more interesting, the story of .NET Standard or the story of how I got here yesterday. But I can tell you more about that over a beer later if you want to know. My name's Adam. I come from the UK originally. I now live in Switzerland. I was actually brought up by Polish parents. So, dziękuję bardzo for coming to my talk. My Polish is very, very bad. I do know a few words, but that's about the extent of it. I work for a company called Particular Software. We are the makers of N-Service Bus. This is the thing that's running the Twitter leaderboard outside, which is currently updating Windows. I do apologize for that. I'll see if I can sort it out after the talk. I'm not going to say too much about N-Service Bus, but what I will say is that we, Particular Software, are a 100% remote working company. So everyone works at home or in one of these. And this is actually my home at the moment. So I've been traveling around this thing with my girlfriend since the beginning of May. And it's working out pretty well. If you want to know more about that, I'm thinking about maybe doing a talk on it or something. So tips and tricks for how to make that work. But back to .NET Standard. So, these are my NuGet packages. These are NuGet packages which I look after. The Fake It Easy is a mocking framework which you may have heard of. LightGuard is one of those silly guard clause libraries where you can go guard against null at the beginning of a method. Xbehave.net is an XUnit extension for using natural languages and tests, and N-Service Bus RabbitMQ is one of the packages that I look after as part of my job at Particular Software. And in terms of .NET Standard support, Fake It Easy supports .NET Standard 1.6, LightGuard supports .NET Standard 1, Xbehave, the beta version of Xbehave supports 1.0, and the beta version of RabbitMQ supports .NET Standard 2. So what is this .NET Standard thing anyway? So like all good programmers, I think we should start with the problem, not the solution. Let's look at what it's actually trying to solve. So I'm going to describe that, and I'm going to take you through a journey of how the solutions to this problem evolved over time. So in the beginning, things are very simple. We had the .NET framework and Mono. So the .NET framework ran on Windows, produced by Microsoft, closed source. It ran on Windows and Windows Server, and Mono was a port of that to work on Mac OS and Linux. So you could, to some degree, run .NET applications on Mac OS and Linux, but through experience, your mileage may vary with that. Then .NET Core came along, and with that you could run your applications on Windows, Windows Server, Linux, or Mac OS or Tizen. Right? Anyone know what Tizen is? Samsung. I heard Samsung from a couple of places. That's right. It's a platform that runs .NET natively on things like TVs and smartwatches and things like that. Then Xamarin came along, and you can run now .NET code on iPhone, iPad, and Mac OS. This is Mac OS with a GUI because .NET Core doesn't really come with a GUI on Mac. Xamarin Android for running it on all the things. Android runs on all too many things to list just here. And UWP, none of the things. No, that's a lie. It does run on a few things. So Windows 10, Windows 10 Mobile, Xbox One, the HoloLens. So the solution to I've gone a bit ahead of myself here, but in order to build applications on those platforms, you want to be able to use NuGet packages. So the solution for that was to be able to use the same NuGet package on any one of the platforms. So you don't want to have to build a NuGet package for the .NET Framework, for .NET Core, for Xamarin. You want to build just one. So the solution to that was portable class libraries in the beginning. Or as I like to refer to it, the portable class library fiasco. And I'll explain why. So in the beginning, as I said, things are very simple. You had the .NET Framework. You would compile your code against a .NET framework, you would run it on Windows, and if everything was very simple. Then this thing called Silverlight came along, or as I mistakenly spelt it on this slide, Sliverlight. But I thought I'd just leave it like that. I like the sound of Sliverlight. And what you would have to do then is, if you wanted to create a package or a library for use on the .NET framework and Silverlight, you would have to compile it twice. You'd have to compile it once against the .NET framework and once against Silverlight. And up until about, I think it was 2010, that's what you had to do. And then someone had the clever idea of, well, they observed first that there is actually an overlap here. So there are some APIs, by APIs I mean methods, properties, etc., that exist in both, right? There's this area here where you know things like system object and int, they exist in both platforms. So wouldn't it be good if you could compile against a set of APIs that represented the overlap, and then use that library or that package or assembly against each of those platforms? So what they did was they created a set of reference assemblies which consisted of only that overlap, and they called it Profile 14. I don't know why it's 14. Don't ask me that question. So using some magic, which I'll go into a little bit later, you would compile against this set of reference assemblies called Profile 14, and you will be able to use that library in either of these things. So good so far? When you introduce a third platform into it, and .NET Core 4.5 was a thing. I don't know who remembers this. I know the version numbering is very confusing, but at this time, .NET Core was 4.5. And they apply the same principle. So why not compile an assembly for all three platforms using a common set of APIs? Why not call that Profile 37? And here we've got Profile 5 and here we've got Profile 14. The more astute among you will notice that Profile 5 isn't just that triangle there, it's actually that intersection there. So that Profile 37 is actually a subset of Profile 5, right? But so this is a little bit contrived, but I'll show you why in a minute. But what I'm trying to do is I'm trying to put the label for those profiles in just the overlap. So you can see that Profile 5 is just the intersection of those two, and likewise with this Profile 14 that we saw before. Right, so far so good. When we introduce a fourth platform into the mix, here we've got Windows Phone 8, things get a bit more complicated still. And this diagram has a fundamental problem. Can anyone spot what it is? The clue's down here. Right, there is nowhere for me to put Profile 14. At least the label. Profile 14 is actually the intersection of that and that. But because there's no clear intersection, there's no intersection of just that and just that, there's nowhere for me to label it. So I thought I could use Venn diagrams for this purpose. And Venn diagrams were first described by a British mathematician called John Venn in the 18th century. And a Venn diagram shows the intersection of all the sets on the diagram. Now it turns out this is not a Venn diagram. This is something called an Euler diagram. And an Euler diagram is a diagram which only shows some of the intersections on the diagram. And this is actually another example of an Euler diagram. So when someone asks me where I come from, all I have to say is, well, I come from England, but is that not Great Britain? Yes, it is. Is that the UK? Yes, it is. Is it the British Isles? Yeah, but you see, all I have to do is verbalize this very simple diagram. And so as I said, this is an Euler diagram. What we actually need is a four-set Venn diagram. And I didn't think you could draw one of those, but it turns out that you can. That's a four-set Venn diagram. And applying our profiles to it, you can see that everything kind of works out again. There's a place here for Profile 14, and it does indeed show the intersection of all the sets on the diagram. Now, it doesn't stop there, right? Things are getting a bit more complicated now, but it doesn't stop there. Down here, we've got a profile with 1, 2, 3, 4, 5 targets in it. profile, what was it, 344. And of course, you can't draw a 5-set Venn diagram. Also, I thought. So this kind of weird, I don't know, what is it, a sort of Frankfurter in a wasabi roll. This is actually a 5-set Venn diagram, and then you can keep going and you can get a bit silly. This is a 6-set Venn diagram. This is a 7-set Venn diagram. It's starting to look quite nice now. And in 2012, a group of very clever scientists at the University of Victoria in Colombia created this, which is the very first symmetric 11-set Venn diagram. And applying our profiles back to this, I found a place for profile 5, but I kind of gave up, and I made up that number. That number has got significance, by the way. If anyone can tell me what it is, I might send you a prize. But as you can see, things are getting really silly now. They're getting out of hand, and I'm going to say that's a fiasco. If you can't even diagram your relationships anymore without a set of PhDs, you're in trouble. Now, fiasco is a little bit harsh. I mean, if I was given this same problem back then, I may have come up with something just as bad or worse. But it became very clear that as all these new platforms started to appear, this just wasn't going to scale. Because every time you get a new platform, you potentially double the amount of profiles. You've got all the previous profiles, plus a new set of profiles with that new platform. So clearly a new solution was required. And that, of course, was .NET Standard. I drew that. And what .NET Standard is it tries to do this. Instead of taking the intersection of all the platforms on the diagram, it just takes the intersection of well, not all the different intersections, but the intersection of all of them only. And it tries to take as big a set of that as possible. So what this means is we've got 5 platforms on this diagram. Instead of having, I don't know what the number of profiles would be. Anyone work that out quickly? If you can, I'll be impressed. But there's only one common thing in the middle. So in order to support these versions, I think that's UWP next, whatever that's going to be, all you have to do is support .NET Standard 1.6. You don't have to choose a profile. You don't have to go through, and the list of profiles is enormous of PCLs, to try and work out which one you should target, because believe me, that was difficult in itself. And the relationship of versions of .NET Standard looks like this. So every version of the .NET Standard is a superset of the version below it. So everything in .NET Standard 1 is included in 1.1, is included in 1.2, and so forth, until the current version, which is .NET Standard 2. And the way that relates to platforms is like this. By the way, the slide deck is linked at the end, so you don't have to try and memorize all these URLs now. But the documentation on this stuff is really, really good. And what this diagram is telling us is that if your library supports .NET Standard version 1, it is usable on all these versions of all these platforms. .NET Standard 1.1 has a few more APIs than version 1, and Windows Phone Silverlight 8 does not have those APIs. So if you instead target 1.1, you will not be able to, your library will not be usable on Windows Phone Silverlight 8. Imagine. So there's one really important thing to note here. As developers, we like the new and shiny. Right? The intuition tells us that 2.0 is the best. So when creating a new project or a package, we should target 2.0, right? Wrong. Probably wrong. As you target the version lower down here, you get to be used on more platforms. As you target a version further towards the right, you are usable on less platforms. And this is a trade-off. 2.0 has the biggest API. You can do the most with it inside your package, but you're going to limit the amount of platforms you're going to be usable on. 1.0 has a much smaller API. You can do less with it, but your library will be usable anywhere. So this is why LightGuard targets 1.0. It's a guard clause library. It does not need any of the APIs that exist in 1.1 and above. Right? So what that then means is, by default, you should really target 1.0. And someone once said to me, when they start a new project, they first target 1.0 and they start writing code. When they find that there's an API doesn't exist in 1.0 that they need, they go to 1.1 and carry on coding, and so forth, until they find the minimum version that they require. But as I say, there's a trade-off at each point. If you go from 1.2 to 1.3, you lose support for these old versions of Windows and Windows Phone. Doesn't really matter. No one really cares. But if you go from 1.3 to 1.4, well, you drop support for 4.6. Some people might be using 4.6, so I don't know. You might want to think about that. But the other interesting thing about that is that as time goes by, those platforms are becoming less and less important. So in a few years from now, it will probably make no difference if you target 1.6. If you target, oh, sorry about that. If that says 2.0 up there. If you target 2.0, that's probably fine. No one's really going to care that you don't support the platforms of 1.6. So this is a kind of a shifting scale. But currently, Visual Studio defaults to .NET Standard 2, and I'm not entirely sure that it should. So that's something to bear in mind. In terms of the version numbering, so .NET Standard actually set out to support Semver originally, which means that you must bump the major version when you make a breaking change. And originally, .NET Standard 2 was going to be a breaking change. So it was going to look like that. So .NET Standard 2 was going to be breaking with respect to 1.5 and 1.6. What that means is .NET Standard 2 was going to be a superset of 1 to 1.4, but there were going to be APIs in 1.5 and 1.6 which didn't exist in it. Therefore 2.0. Now, when this was announced, and it hit Twitter, the community kind of threw their toys out of the pram and said that's no good. And the .NET team kind of listened to that feedback and said, okay, we'll change our mind, we'll actually make it non-breaking. So this is what it looks like now. At this point, they could have made it 1.7, right? Not breaking anymore. But they decided to stick with 2.0, and that's fair enough. Semver doesn't stop you from bumping the major. It just says you have to when you make a breaking. And I think it's probably quite justified, because we'll look at the changes in 2.0 in a minute, and it is quite a fundamental change. As I said, the documentation on this is fantastic. This is a diff between 1.4 and 1.3. You can diff every single version of .NET Standard with the previous one, and it will give you a full list of what's been added. 1.4 to 1.3 is very small, as you can see. And how does this work? So I think the most important thing first is to separate creating the package, building the package, to consuming the package in an application. Two very different scenarios. So when you build a package, things are very, very simple. You create your .NET Standard class library, and that references a thing called Net Standard DLL. And Net Standard DLL is actually a completely empty DLL. Well, not entirely. It has method and property signatures, but they don't really do anything. This is actually it here. So this is I'll just see if I can get that out of the way. So this is Net Standard 2, Net Standard DLL. And if you actually drill into it, there's basically nothing in it. So it goes something with methods. There you go. So you can't actually have nothing inside something which returns a value. So you see the properties throw null. Throw null. Did you know you could do that? You can in IL. So you can't do it in C#, but the CLR actually allows you to throw anything. You can throw an int or a bool. I don't know why you'd want to, but clearly this wasn't written in C#. This was generated IL. So it's throwing null because it's the absolute simplest, smallest bit of code that can exist, whilst it's still being a valid IL assembly. And you can see that things that don't return anything like that are just completely empty. And that is because the Net Standard DLL is nothing more than an interface. You never actually run against it. You compile against it and you run on the platforms. Then if we look at actually consuming this in an application, things are a little bit more complicated. You've got, say, your .NET Framework application here. That references the .NET Framework assemblies, e.g. MS Core lib. And then the Net Standard class library, as I showed you before, is referencing Net Standard DLL. However, this is a different Net Standard DLL. What's inside it is actually different. And what this actually does, it uses a thing called type forwarding. Type forwarding is something that's been around since, I think, .NET 1. And all it does is it allows an assembly to say that it contains a type, but when the runtime actually tries to use it, it says, actually, no, it's in this assembly over here. Right? Because it's important to remember that the definition of a type, or the name of a type in .NET, is not just system object. It's assembly name, type name, and version and public signing key and stuff. So system object is actually MS Core lib system object. So what that means is the .NET Framework application up here thinks system object is in the MS Core lib. The .NET Standard class library thinks system object is in that Standard DLL. When the runtime executes the application, and the application calls into a method here with system object and its signature, the CLR will say, oh, not Net Standard system object, right? It will go here, look in here. This Net Standard DLL will point back to MS Core lib in the framework, and then the two match together. So I'll show you what that looks like. See, this is the Net Standard DLL that comes with, it's in a weird Visual Studio folder, but essentially it's the Net 461 Net Standard DLL. So the .NET 4.6.1 Net Standard DLL forwards types, as you can see here, type forwarded to MS Core lib. Unfortunately, when I click, it doesn't go to it. I think it's because I have .NET 4.7 on my machine, and then there's more type forwarding that goes on at the GAC level from 4.6 to 4.7, but ILSpy doesn't respect it. So there's type forwarding going on everywhere. But the point is that this Net Standard DLL is not the one that's used when building the package, right? That Net Standard DLL, part of Net Standard. That Net Standard DLL, part of the .NET Framework. Make sense? I see a few nodding heads, so I'll go on. As I said, 2.0, right? Really, really big change, and I think the keeping the 2.0 version number is actually justified. And the reason for that is because 2.0 is a big change. The .NET team took a lot of feedback on .NET Standard 1, and the two main bits of feedback they got were limitations and paralysis. So what do I mean by limitations? Well, as you can see in this diagram, .NET Standard 1.6 is quite small, right, compared to the other circles, and it's actually not a bad representation. So the number of APIs in the .NET framework, or in even Xamarin or UWP or anything, was a lot larger than .NET Standard. It only took a relatively small subset of those APIs. So you were quite limited in what you could do. If you're trying to port your library, you'd soon find APIs that you needed, like things like IDB connection. IDB connection didn't exist in .NET Standard 1.6. So .NET Standard 2 aimed to do this, right? Much bigger circle, much bigger API. And what that effectively means is that it's drawn these platforms closer together, because all these platforms now have to have more of the same common APIs. And the difference again is vast. You know, the size of the circles again is quite representative. .NET 1.6 had about 13,000 APIs, i.e. methods, properties, etc. .NET Standard 2 about 32,000. So massive, massive change. And what the .NET team have done is they've tried to look at the .NET framework and .NET Core and things like that, and try to pick out all the APIs that they think make sense on all platforms. So things like IDB connection, yeah, you're probably going to want to query a database on most platforms. IDB connection came into the standard. System registry doesn't exist on Linux and Mac, so you're not going to have it in .NET Core. That didn't make it in. Right, so a much, much bigger set of all those APIs that will work on all platforms. And earlier on I showed you the diff between .NET Standard 1.3 and 1.4, if you try and look at this for 1.6 2.0, GitHub just gives up. It just says it can't show a file that big. So if you want to see that file, you've got to clone the repo and have a look at it locally. So it really is a vast, vast difference. And that largely takes care of the limitations. The next thing is paralysis. So what do I mean by paralysis? Well, most NuGet packages tend to depend on another well, maybe most is an exaggeration, but a lot of NuGet packages depend on other packages. So Fake It Easy depends on Castle Core. The NService Bus Rabbit integration depends on NService Bus, obviously, and the RabbitMQ client. In turn, NService Bus depends on AutoFac and Newtonsoft.json, although it actually internalizes them during compile time. And this is not unusual. Sometimes you can get dependency change which are very, very deep, sort of 4 or 5 packages deep. And at the bottom, everything kind of depends on Newtonsoft.json. So this is a problem. If you want to retarget your package to .NET Standard, at least in the 1.x days, you couldn't do that until your dependencies supported that version of .NET Standard or a lower version. So for instance, with Fake It Easy, we had to wait about 6 months before we could release a Fake It Easy stable package targeting .NET Standard because we were waiting for Castle Core. Right, and that's just a very simple example, but the problem is that this rippled out throughout the community and everyone was in kind of deadlock, waiting for the dependencies at the bottom to be converted to .NET Standard. JSON.NET luckily got ported to .NET Standard quite early on, so that unlocked a lot of the problem, I guess. But this problem still persists today. So what is the solution to that? Well, reference anything. Right? Sounds too simple, it sounds too obvious, and there must be some magic involved. How can you just reference anything? But some very clever people in the .NET team worked out that they could do this, because if you look at all the packages on the NuGet gallery and analyze them, all the ones that are just written for the .NET framework, 70% of them are only using APIs that exist in .NET Standard 2. So that means that you should theoretically be able to pick up one of those packages and just run it under .NET Standard 2.0, because it's using methods and properties that exist in it. Right? So, but this did need a bit of magic to work, and the first time I saw it working, I was quite amazed. So let's have a quick look at it in action. So .NET Standard magic. So what I've got here is a .NET Standard application. So if you haven't seen this is just another project type supported by Visual Studio now, .NET Standard, and it's supporting .NET Standard 2. Then I've got a .NET Core app. That is just a .NET Core 2 console app. What I'm going to do now is install a package called Power Collections. And this is a package which hasn't been recompiled for a very long time. It's a really useful package. Is it going to find it? Yes. And I'm just going to go ahead and install that in the .NET Standard 2 assembly. Okay, so that worked, I think. Right, so you can see there's a little yellow warning symbol here. Right, I think you can probably see it. And when I build, I also get a warning. Right, I get a warning, NU1701. The package was restored using .NET Framework 4.6.1 instead of the project target framework .NET Standard 2. Right, so it's giving you a warning. It's saying, well, I've installed it, but just so you know, this is actually a .NET Framework package, right? Just in case you didn't know. So probably good to know. And you can actually get rid of that warning if you go to if you edit the project file and you put in this no warn here. So if you know, if you're happy, yes, okay, thank you for letting me know, but I know that this package isn't going to work. You just ignore it like that, and that should get rid of the warning. Instantly, it doesn't. It gets rid of the icon straight away, but it doesn't get rid of the this warning straight away. That happens the second time you build. So obviously a few little things to work out here. Anyone know what 1701 is? Any geeks in the audience? Star Trek? NCC 1701. That's USS Enterprise. Oh dear. Right, so back to business. So what I'm going to do here is I'm going to actually use something from Power Collections. It's something called a bag. And I did a using statement. I'm going to compile. And so far so good, so it's compiled. Now what I'm going to do is reference the .NET Standard library from the .NET Core app. Right, and again, you get the yellow warning, and you can't get rid of it, even if you put the warning, even if you put no warn into the .NET Core app CS_proj. So again, a couple of things to iron out there. You just got to live with that little yellow triangle. I'm then going to use something from the .NET Standard library. Not really too important what this code's doing. It's just using something in that library. And I need another using. And I'm going to run that. And it works. Right, so what you have there, we've got a .NET Core 2 app referencing a .NET Standard assembly, referencing a .NET Framework assembly. Right? And it just works. So that's pretty cool, and there must be some magic going on there. So let's have a look at what that is. Again, we need to separate building the package from running the application, two different scenarios. So when you build the package, this is how it looks. The .NET Standard class library references .NET Standard DLL, just as it did before, and the .NET Framework class library obviously references the .NET Framework assemblies, e.g. MS_core_lib. Now, when you compile this is not the MS_core_lib that you think it is. It is not the MS_core_lib in the GAC that's installed by the .NET Framework. It is an MS_core_lib that comes with the .NET Standard. Right, this magic of type forwarding again. And I'll show you that. That's Power Collections, by the way, just there, just to prove it to you. It's actually a .NET Framework 2 assembly, so really, really old. So this is the MS_core_lib that comes with the .NET Standard. And because it's the MS_core_lib that comes with the .NET Standard, it type forwards everything to, that's interesting, registry. It type forwards everything to here, which is .NET Standard. Right? Does that make sense? So when the class library passes system object here, that's .NET Standard DLL system object. This thing here wants MS_core_lib system object. It looks in here for MS_core_lib system object. Type forwarding tells us actually it's not standard. .NET Standard system object, and the two match up. When you're running your application, it's a bit more complicated again. Here's your .NET Core app. That is referencing the .NET Core assemblies. Things like system.runtime, I think is the equivalent of MS_core_lib. The .NET Standard class library is referencing .NET Standard. This, yet again, is another .NET Standard DLL. This is the .NET Standard DLL that comes with .NET Core. And it tells the runtime that system object doesn't live in .NET Standard DLL, it actually lives in system runtime, or something like that, in .NET Core. I'm not a .NET Core expert. .NET Framework, the .NET Framework class library references the .NET Framework assemblies, again, MS_core_lib. This is yet another MS_core_lib. This is the MS_core_lib that comes with .NET Core. So again, the runtime is saying, oh, you want MS_core_lib system object. It looks in here. This tells it, no, system object is actually in system.runtime system object. So again, everything resolves back to the system runtime system object. Clear as mud? If you don't get it right now, don't worry about it. It took me a while to sort of understand it, and I still have to refer back to this to remind myself. There's a lot of type forwarding going on here, but so you don't really have to worry about most of this, but it's interesting to know what's going on under the hood. And I can show you these assemblies again. So this is the .NET standard that comes with Net Core App. So this is the one that's forwarding stuff back to system.runtime, which is the Net Core App actual runtime. And you've got the MS Core lib down here, which is pointing the .NET Framework assembly back to the .NET Core runtime. Right? So this is the .NET Core version of MS Core lib. Right? And this is actually a simplification. So if we actually look inside here, so this isn't actually, so if you look inside here, right, again, this is one of these empty assemblies. So this is just used to compile against. So what happens is when you run, this is actually besides the point, this is .NET Core internals, not really .NET Standard. But when you run a .NET Core app, it doesn't actually use this assembly from where is it? This NuGet fallback folder. It actually uses this, which is the .NET shared. That's the actual runtime DLL when you actually run a .NET Core app. And you'll notice that this actually type forwards. So this actually type forwards to a thing called, wait for it, system.private.corelib. This is, and if you look in here, this is something that at last finally contains some code. So this is the actual thing that runs at runtime. So moral of the story is type forwarding everywhere. When you run a .NET Core app, the type forwarding is immense. It's going on several different levels and several different directions. But don't worry about it. Just run your .NET Core app. Okay, so actually what I thought I'd do is, because it's cool that works, but then I thought, well, why don't I just cut out the middleman? Why don't I just cut out the .NET Standard assembly and see if I can just reference a class .NET Framework assembly from .NET Core? So I thought I'd give that a try. The .NET Core magic. So I'm going to install Power Collections again. And again, you get the warning, which you can get rid of. You can actually get rid of it this time because the libraries and the package is installed directly into the app. And I'm just going to use it again. And who thinks this is going to work? No one. Does anyone think it's going to work? Oh, you're so pessimistic. I was as well. I didn't think this was going to work, but it works. Right? I'll give that a moment to sink in. Right? I've just created a .NET Core app, and I've just installed a .NET Framework package into it, and it works. That's quite profound. It means you can now develop .NET Core apps, in .NET Core 2, and you can use all the packages that have been around since the beginning of time on NuGet in your app, in your .NET Core app. Okay, granted, 30% of them are going to try and call into APIs that break something. So you've got to watch out for that. Testing is quite important. But ultimately, this is not. I don't think this is viewed as a long-term strategic solution. This is kind of like a hack to get us past this paralysis. Eventually, I would hope that most packages on NuGet support a version of .NET Standard, and we don't even need this particular bit of type forwarding magic anymore. These various hundreds of versions of MS Core lib and all the rest of it. But for now, it definitely unlocks us a little bit, because there's no more frustration of creating that .NET Core app and then being disappointed when that package you've always wanted to use doesn't support .NET Core or an appropriate version of .NET Standard. So that's pretty cool. So as I said, this does have a sort of element of works on my machine, because who knows, unless you kind of test it on all those permutations that you think it's going to be used on, like on Mac and then Linux and everything, you can't really be sure it's going to work. But this is a really good resource. On this page, they actually tell you the APIs on all different platforms that are actually not supported, although the platform says they support them. So what this is telling you is that on Linux, this method, the setter of max working set, will throw a platform not supported exception. And likewise on OS X, for other processes, this will throw a platform not supported exception. So this is quite important to know if you're using some of those APIs. So try it. If you want to try this, install .NET Core 2, because that installs the .NET Standard 2 bits. Two things are still a bit conflated together. And then your IDE of choice, any of those versions will do. Those are the repos I've just showed you. The No Magic one shows you what happens when you try and reference a package which doesn't, which calls into something that .NET Standard doesn't support. I don't have time to show you that right now, unfortunately, but it just throws an exception. So with this reference anything, that's largely taken care of the paralysis, hopefully. And that in a nutshell is .NET Standard 2. More APIs, reference anything. So port my package. If I want to port my package to .NET Standard, what do I do? There are a couple of really good resources. Check compatibility. This is what you can do is you can say, take this DLL, run analysis of it against these platforms, and tell me what percentage of the APIs I need are in those platforms. So to give you an example, so you can run it in .NET in Visual Studio just by going Analyze Project, and this will spit out, or you can do it in the console, and this will spit out, of all things, an Excel file. And in that Excel file, you will see something like this. So I ran it for NService Bus. As I mentioned, NService Bus Beta supports .NET Standard, but this is the current stable version. It targets .NET 4.5.2, so not surprisingly, 100% of the APIs are present in .NET 4.5.2. In .NET Standard 1.6, it only has 66% of the APIs that NService Bus needs, so not ideal. In .NET Standard 2, it has 87% of the APIs that it needs. And we've been able to overcome that 30% gap, and then Service Bus Beta now supports .NET Standard 2. But this gave us a really good idea of how difficult it might be, and we just said .NET Standard 1.6, not worth it. It's not worth trying to close that gap of 34% to try and support .NET Standard 1.6. Let's wait for .NET Standard 2 and support that instead. So what do I do when I'm faced with this problem, when I've got this gap I need to close? Well, you can change things. You can change things internally, avoiding a breaking change. You know, if you're using some APIs internally and another API can do the same thing, which is in .NET Standard, switch to that API. If that's not an option, change your public API. Right? That means a breaking change, which probably means you have to update your major. So not as nice, but that's another option. You can separate stuff. So for instance, in the current NService Bus stable, the MSMQ transport is embedded into it. So you get that with the core package. MSMQ doesn't exist on Linux and Mac, so that's never going to be part of .NET Standard. So for the beta, we've pulled out MSMQ into a separate package. So the core, you don't get that, then you choose your transport. If you want MSMQ, fine, install it, but you're limited to the .NET framework. If you want to use Rabbit, install that, and then you can use that on Linux or Mac. You can remove. At the end, it might be an excuse to get rid of that API, that ugly thing that you wanted to get rid of for years, that no one uses. You know, that's probably the last option, but sometimes it's the better one. APIs and versions of .NET. This is a very good resource. if you go in here, you can actually search all the types and all the methods and all the properties that have been in any version of the .NET framework, the .NET Core, .NET Standard, all variants of .NET since the beginning of time, and it will show you the definitions, the methods, everything. It will show you which platforms and which versions of .NET Standard it's supported in. So this is IDB connection. As you can see, it's in all the versions of .NET Framework. Not unsurprisingly, it's only in .NET Standard 2. Okay, it came back in that one. That's the one I mentioned earlier. So that's a really good resource to use. .NET Standard versus .NET Core. One of the original reasons I wanted to give this talk. When I asked on Twitter whether people were still confused by .NET Standard and .NET Core, the answer was a resounding yes. People didn't understand the difference between the two. They were too conflated in all the communication and marketing material. I'm hoping that through this talk, the differences have become somewhat apparent. .NET Standard is kind of like an interface. It just defines a set of APIs that a platform must implement. So you've got, and .NET Core is another platform. So the platforms are .NET Framework, Xamarin iOS, Xamarin Android, UWP, .NET Core. It is just another one of those platforms. And they all in turn implement a version of .NET Standard. So .NET Core actually has no stronger relationship to .NET Standard than the .NET Framework, or Xamarin iOS, or Xamarin Mac. It is a peer platform of those. The problem is that the communication is that it does conflate the two. So this is actually the release schedule for .NET Standard 2, and surprisingly, or pleasantly enough, these deadlines were actually hit, or these forecasts were actually hit. We actually did get the preview in Q2, and we did get RTM in Q3. But as you can see, this is in the .NET Core repo, and if you actually go here, you actually see this. You see .NET Core and .NET Standard, .NET Core and .NET Standard, and then we've got the next versions of .NET Core coming out. So be prepared for more of that. You're going to hear about .NET Core and .NET Standard in the same sentences. This is not going to stop. But I hope that after this talk today, you've got an understanding of actually where these things fit in together and what they actually are and what their differences are. This is another way of explaining this. I thought I'd just throw this in here. I hope this doesn't undo all the good work I've done. But this is something that David Fowler came up with. It's an analogy. He's taken the versions of .NET Standard, made them interfaces, and then he's inherited from them with different platforms. Right, so you can see that UWP10 only implements .NET Standard 1.4, doesn't implement 1.5, but these ones do. Right, so some people find that useful to look at. If you want to know more about that, go to the repo and have a look. Some people find that also a useful way of looking at it. .NET Standard 2.1, 2.2, and 3. Right, so 2, all very well and good. What happens when 2.1 comes along and 2.2 and 3? Does this make it more difficult for platforms? Is there a burden on platforms then to support more APIs? The answer to that is yes, obviously. If 2.1 is going to be a superset of 2, it's going to introduce a few new types of methods. If you as a platform want to support .NET Standard 2.1, you're going to have to add those types of methods. There's no getting away from it. However, given the enormous amount of change between 1 and 2, I think what's happened now is the bulk of the change that will ever happen. So yes, we're probably going to get a .NET Standard 2.1. Maybe there is going to be maybe there are going to be a few new types that are introduced. Let's say in .NET Core will submit that back to a thing called the .NET Standard committee, and they will actually just say, yes, that API makes sense on all the platforms, or no, it doesn't. If the answer is yes, they'll submit it for a future version of .NET Standard. But I think it's unlikely that we're going to get a massive change again like 1.0 and to 2.0, because, as I said, that's actually taken most of the APIs from the platforms that make sense on all the platforms and put them into a standard already. So I'm not entirely convinced there'll ever be a 3.0. I'm not sure there'll ever be a reason for it. unless they decide to backtrack and actually make a breaking change, but I think that's unlikely. So my prediction is 2.1, 2.2, yes, 3.9, maybe never. But I'm happy to be proved wrong. So how do they do? So who now feels they have a reasonable understanding of what .NET Standard is? And that's quite a few of you. That's good. And who has a good understanding of the difference between .NET Core and .NET Standard? Almost all of you. Excellent. So I should have asked that question when you came in, but you may have all come in knowing that. But give myself the benefit of the doubt and say that maybe I contributed a bit towards that understanding. So that's good. Now, those of you who didn't put your hand up, I'm running a bit over, but I started a little bit late. Those of you who didn't put your hand up, what are the questions that you've still got? Are there any things that you still want me to clarify? This is the Q&A bit. Anyone? Any lingering doubts? No? Going once? Going twice? Okay. So, just to round up, I've been talking about NService Bus a lot. If you're interested to know more about NService Bus, go to that intro. We've got a nice intro to it. And if you're more interested in what we're doing to support .NET Core via .NET Standard, have a look at the second URL. We've got a lot of information there. Spiel over. This is a tweet that this guy Martin sent early in, or actually I think it was back in, there you go, December 2016. And he said, .NET needs better tooling in 2017. 2016 was rough. And I agree with that. So I think 2015 and 2016 was a bit of a rocky road in terms of the .NET Core SDK, the .NET Standard, and all these kinds of things. But at the time, I agreed and I was very optimistic about the .NET tooling in 2017. And 2017 is coming to a close in a few months, and I think the progress we've made in that time is quite substantial. The .NET team have actually hit their deadlines. We actually got .NET Standard and .NET Core when they promised. And now they're promising .NET Core 2.1 next year, and it looks like we're probably going to actually get it. So I think things are looking up. Things for me now, especially with the new tooling in VS 2017, although there are a few bugs, are back where we should be going. Now we had the whole Project JSON thing and the renaming of the .NET Core CLI through. Do you remember Project K and then DNX and all that stuff? Well, we're back on .NET now, so I think we're back in a good direction now. And the reason I wanted to talk about .NET Standard, because that has value independently of the platforms. So .NET Core could cease to be a thing tomorrow, but .NET Standard would still have value, because you'd still want to use the same package on .NET Framework, Xamarin, etc., etc. .NET Core, on the other hand, could exist without .NET Standard, but you'd be back to this kind of like having to compile for every single platform. So, you know, .NET Core, I must admit, I haven't done much in .NET Core yet, but .NET Standard for me is a technology that has already proved itself and already feels like one of those things where I say that's the way it always should have been, especially compared to portable class libraries. And when I look at .NET Standard 2, I think that's the way that .NET Standard should have been from the beginning, which is obviously very easy in hindsight. So that's me done. So go to my slide deck if you want to go to any of those URLs. My Twitter handle's been on the top of the slides, getting in the way of some stuff. Please ping me if you've got any more questions. I'm going to be around for the rest of the day and tomorrow, so do come and talk to me and ask me those questions which you were too afraid to ask by putting your hand up now. I hope you've enjoyed the talk. I've really enjoyed talking to you. Enjoy the rest of the conference, and thank you very much.